Hello, and welcome back to my YouTube channel. Today we are going to continue with the Programming 101 series and we will talk about data types and variables. Um, First, I want to talk about what a data type actually is. Well, you can think about it in two ways. First, it has a representation, meaning the way it is stored in the memory, and it has a behavior, meaning the stuff you can do with it, how it behaves. Um, and a variable is just pretty much a name for it. So you can actually address this value you want to put in that variable, and it has to be and a variable has to be of a certain data type to be able to store the necessary value. There are languages which do not really differentiate between the different types. They are not typed languages, but I'm going to talk about data types today, where it actually matters what you store in them. So without any further ado, let's just jump into Visual Studio. I'm going to put myself in the bottom right corner as well. And yeah, so there are basically four different data types, like four different fundamental data types. You can make your own data types as well, but this is not the topic of this episode. I will talk about this in the later episode. Um, Today we are going to talk about the four fundamental data types, and they are um, integer values, floating point values, character values, and Boolean values. So I will actually use C++ reference to talk about this stuff because there's a very nice overview about this. And just open a browser and search for C++ reference and fundamental data types, and you will get on this page. And we're just going to jump down to integer because we're starting with integer. So integer values are like integral numeric types without a fraction. They have like different sizes. There are different types of integer values. You can see that here. There's like a short for a shorter number. There is the normal integer type, and you have like long and long. Now you see, like in this table to the right, there is a smaller table which says like the data model, and we are concerning ourselves with the LLP64, since this is the Windows 64-bit data model. And the sizes you can see here, and size actually means like, or they're calling it width, because it's the like width of the field in the memory. And they say that a short int is 16 bits, a normal int and a long int are 32 and 32 bits, and long is 64 bits. So what does that mean? Well, that means that a short integer will use up 16 bits of memory. So if we are imagining the memory as a table, which is actually quite a good comparison, and let's just think about that each of the cells of this table is like 1 byte, meaning 8-bit. Then a short integer value, let me put this just next to each other so we can see this better. A short int would actually use 2 bytes, yeah? Like 1 byte are 8-bit. A short is 16 bits, so it's 2 bytes. So it would take up those two slots here. An integer value and a long value are 32 bits, meaning 4 bytes. So that would be this space. And a long value, which is 64 bits, so 8 bytes, would use this space. And that's what width means. But you can look at this width value from another angle as well, meaning the size of the number you can store in that variable. So let's jump back into Visual Studio. And I added a new file here, 02 data types and variables, and you can do this by right-clicking on the project and go on Add New Item, choose the source file, and then just put the name down here and click on Add. And I already put in the main function as well, which is the main starting point for every C++ program. Every C++ program needs a main function. And to define like an integer value now, you just write int value or the name. Like you can choose any name. It could be Hugo or I don't know, Honolulu as well. But I just call it value. And let's just give it the value of 5. So to get back to the size of the data type, we can use a operator called sizeOf to see the size of a given data type. So I'm just going to change this to integer size equals sizeOf, and then the data type int, and we print this value. Size colon, we print size as well. And if we run this, it gives us a 4. Let's go back to the C++ reference. We can see that integer is 32-bit, so that's 4 byte. And let's try short, long, and long as well. So we try short, which should give us 5, 2. Then long, which should give us 4 again. And then we go long, and that should give us 8. And always multiply this by 8. For 1 byte is 8-bit, and 8 times 8 is 64. And we see 64 for data model LLP64. The question is now, what does it mean though? Like, what does this 4 bytes mean? Well, it's pretty much the maximum like size of the number you can store in there. But there's one more distinction we have to make to explain this completely, and that is this variable now is a signed integer. Like that's the default. If you don't put that in front, you can write signed as well, or you can also write unsigned. This means that an unsigned value cannot have a sign in front of the number, so they are always positive or 0, while a signed value can have a sign in front of the number, and that can be negative, 0, or positive. So let's just check that. Let's put in a -1. Oh, that doesn't work. We get a -1. I just put in a 0. We get a 0. And I put in a 1. And we get a 1. So now let's change this to unsigned. Again, 1 just gives me a 1. A 0 gives me a 0. What does a -1 do now? Well, we'll see. Oh my god. That's 4,294,967,295. So what is that? Or what happened here? Well, what happened here is an underflow, meaning that this variable, since it has no sign in front of it, it can only be positive. It cannot hold negative values. Like only signed integers can hold negative values. So if we put signed again, we see a -1. And the number we saw there actually is the max value for an unsigned integer. And you can also get to this value by another way, and that's the more well, let's say the more scientific way. Just remember that a signed integer is 32-bit, or like an unsigned integer is as well 32 bits. So let's just take out a calculator and calculate. Let me just start that again, and we calculate 2 to the power of 32 gives us that value. which is just one larger than like the actual value we got, and that is because we have to like take the 0 in there as well, meaning that you start with 0, not with 1. So you have to subtract 1 from this value and you get that one. So if we just do this again and I copy this and then I paste this here, we will actually see this value as well. Yeah. If we go to that value, which is then we see a 0 because it overflowed, so it starts back at 0. Like you have an underflow, which is pretty much to the left, and you have an overflow, which is to the right. So if you go like with an unsigned value, you go on like lower than 0, you get an underflow. And if you go larger than the max value, you get an overflow. But what does that mean for signed integers? Well, that means that they can only store half of this value because they have to store the negative half, 0, and the positive half. And if you go back to the C++ reference, we can see that here in the bottom as well. You can see a signed, like a 32-bit signed integer can hold values between negative 2,147,000,000 blah 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 to positive 2,147,000,000 blah blah blah, while an unsigned integer can hold values from 0 to, and that's the value we saw there as well. And just to complete this, let's just quickly like walk through the other integer types. We can just use the signed ones now as a default. This unsigned and signed business applies to all the integer types. So if we use a short, and I'm just going to call this value here because it doesn't really matter. Like, let's just say we have a short and we take the size of a short data type. We don't even have to do this. We can just keep that on int. Then like short size is 2 bytes. So meaning 16-bit. And jump back to that again. You see short is like they can like assigned can store from like negative 32,768 to positive 767. There's a 0 there again. Like don't forget that. That's why you have here like 67, not 68. And then you have like that unsigned goes to 65,535. And if you do this for long here, you get 4 byte again. It's the same size than an integer. You can see that here as well, 32-bit. Or you can see it rather here because like an integer, like the normal int is 32-bit and the long as well. And we can, like there is one data type that is larger than the others, and that is long, which is like an 8 byte. And that's 64-bit, meaning you can store a ridiculously large number. Let's go back to the other table. That is, yeah, whatever. Like, I don't know. Like unsigned is, so that is 100,000, 100 million, 100 billion. Yeah, so, and a ridiculously large number. Yeah, and that's it for the integer types, really. So next up are floating point values. If we go back to the C++ reference, we can see that there are 3 different types. That's float double and long double. And like the difference between them is the precision, meaning how many decimal digits they can store. If we click on this link here, we get to a Wikipedia page, and you can see a 32-bit floating point has 23 bits for the fraction and 8 bits for the exponent and 1 bit for the sign. And the 64-bit layout is similar, but it has a like a 52-bit width for the fraction part, and then you have 11 bits for the exponent. Then you have like 1 bit for the sign again, and that extended floating point has like 80 bits in total. So if we jump back to Visual Studio, let's just make a float, like an f. Float f value is 5.42 for 3. And then we have a double, and we give that the same value. We print those two, float value, double value, and copy paste. And we will see the same value. That is because like they're not the same. I mean, well, they are the same, but if you have this and this, you can actually see that like they have the same amount of decimal digits. It's really a tough word, or like tough words, decimal digits. And I mean, but in reality, like they have a lot more of those digits. But for the purpose of printing this to the console, it gets rounded to 5 digits. They are automatically signed, like there is no unsigned or signed keyword you can put in front of them. If you do that, you get a compiler error. So we can negate them as well. And just to make it complete, let's show that for the float value as well. Negative and positive is possible. Okay, and yeah, they can only store like numeric values, and that's pretty much it already for them. So next up are character values, text. If we go to the C++ reference again and we search for character types, we get a couple of types as well, 3 different types. We will ignore signed char and unsigned char because they are actually used for, like they are something like C++ specific. So we will concentrate on the char, and there are 2 different ways to go about this. So like if we only want to store one letter, let's say G, we go char letter equals and then single quotes G, done. And let's print this. So char, or let's say single char value is letter, and we print this and we get a G. So what if we want to store like a name now? Let's see, like G, like Gandalf. Yeah. So what we have to do is we have to make an array, and like just accept the fact that there is something called an array, and you can store several elements, like multiple elements, actually a lot of elements in there. So we say char and then name, and then you have those 2 square brackets here, and they indicate that we are making like a character array now. And now we have to use double quotation marks, and now we can say Gandalf, and we can print that as well. We call that name and say name, and that should print Gandalf. Yeah. So there we go. I will get into the details of that as well, and there's also it's not a fundamental type, but it's let's say a very fundamental type called string, which is like an object. Like it's not a basic type anymore. It's like you can say it's a custom type from the C++ library, like which handles strings. or text. And I will get into that type in one of the later episodes. But for now, we just say there are like one single character is a char, and then you have a char array, which is denounced by that, or which is like which is named with the 2 brackets, and you can store like anything in there. You can just say kind of like whatever Gandalf the gray, and later the white, and we will see that as well. Alrighty, and that's it for character values. So now for the last fundamental data type, which is Boolean. So Boolean is not just a fundamental data type in C++ or in any other programming language, but is actually fundamental to the entire like computer science. Boolean means that you have an expression which you can evaluate into true or false. So is she my sister? True or false? Yes or no? Are you my brother? Yes or no? Or something like, is 1 equals to 2, which is false? Or is 1 equals to 1, which is true? You give them, they are called Boolean or bool in C++. And let's just say we call this compare. So you can say, you can initialize them with true, or you can initialize them with false. And this true or false just like eventually boils down to 0 or 1, where 0 is false and 1 is true. So if we print this Boolean variable and we set it to false, you can see a what is that now? I did not exchange that one. You can see a 0. If we put this to true, you can see that like it evaluates to 1. So what are they used in? Well, they are mostly used when you have to make a decision, obviously. Like if something is equal to something else, or if something is smaller than something else, or if 2 strings are the same. So they are often used in if statements, and I will introduce if statements in probably the second episode from now. The next one will be about functions. But for now, we just accept that there is something that is called an if statement, and you write them like this. So this is now like invalid. The compiler will give an error because, like as it said already, there is an expression which we have to put in there. So now we can say if compare, now equals are 2 equal signs, true, then print, just print true for now. And let's just put another one after that. And we say compare, if compare, so you can read this like if compare equals false, then do print false. Okay. So now we delete that one and we set it on true, so it should print true. And it prints true. Or we can also put something compare is true, compare is false. So compare is true, okay. Now we set that on false, and now it prints that compare is false. Yeah. And as you can probably already imagine, this type is very, very important when you like when it comes to programming and to algorithms and more complicated algorithms. So we will use this a lot in this series. And just to complete this, we will look in the C++ reference again, and it's a very short paragraph here. It says, bool type capable of holding only 2 values, true or false. And that is just some like compiler specific stuff here, that the value of size of bool should like return a 1, but it can also return something different, but that is not important for us now. Most important, they can only hold true or false. What you could do is you could also say 0 here for, and if you do that again, it's obviously false. And you can also put a 1 in. That was the wrong line. You can put a 1 in here, and that will evaluate to true. Alrighty, so that's it for today. Next episode, we will talk about functions. And yeah, I hope you enjoyed this. If you did, then click the subscribe and like button. And see you next time. Bye bye.